Greetings. Hello. Oh, that tastes like swimming pool water. Greetings. I've had some technical problems, so I don't know if any of this is working. I think the sound is working, probably. And the webcam appears to be... Yeah, it was going all funny. Let me tell you, it did not look good. Also, the size is probably different. I don't know how big I don't want it too big because I don't want to cover up the code. But I don't want it too small because then you cannot see. Whatever. Cool. What were we doing? Yes, last time I coded some terrible voxel stuff where there would be some collisions, but ultimately things would just sink into the voxels like a weird 90s anime. So that's cool. No, wait, no, it sucks, that's right. Anyway, as always, taking song requests. So if you have a song you want, just, let me know, and I probably won't recognize it. Okay, so I did a bunch of reading on impulse-based collision responses, and you have to do things like retain collisions between frames, or use a solver, or do fancy stuff that I'm not really interested in implementing. But the worst / easiest way of getting a impulse-based solver to work in a fairly consistent way is to wind back the collision and work from there, which in realistic terms is a very simple case. When we detect a collision, we revert the position to what it was before. Now this is extremely hacky, but just to check if it works in principle, let's give it a shot. So ideally you want to wind it back to the point of collision, but I'm just going to wind it back until the start of the frame because that is at least before the collision. Now if this, you know what? That looks a lot more reasonable. For one thing, it's not sinking into the floor. Why don't I make these spawned desks also behave in such a way? So I'm just going to give them the physics entity and give them some kind of bounding box. So now we can see what we've got. Well, that looks pretty nice. I mean, that already looks pretty good, but none of these things are going to be moving particularly fast. Dare I just say that's good enough? No, it's not going to be good enough when things are going to be moving quickly. But at least you can see that things are behaving. Let's get to an interesting thing. Oh, that's jammed in the wall. There we go. that's kind of doing the right thing. The right thing is maybe an overly prescriptive choice of words, but it's certainly better than sinking into the floor. But it's not really optimal, because if something's going fast, it's going to bounce in a very strange way, especially if it comes in at an angle. Let me draw this in paint. Although now that I think about it, if the time step was fine enough, maybe it would be fine. I don't want the physics to be really complicated, I just want them to not suck. So if we can make them very simple but have a very fine time step, that's probably better than making them slightly more complex with a more grain, because it's going to get so weird and complicated when things can crash into themselves. So if that's the level, and we have a little box coming in, it comes in here, the next frame it's here, then the next frame it's here. Then it's going to rebound. You would expect it to rebound like that. So you'd expect it to go like that. Let me draw the centers in. So from here to here, that's the collision path. But you'd expect it to rebound like that. Just winding back the box will make it rebound like this, which is a bit higher than you might expect. As if it's not really colliding with the wall. But then again, if this distance is small, I actually really, I don't know if I care. Do I care enough? Do I care enough? I mean, it's basically kind of, gosh, it's difficult. It is difficult to think about what would be best. So the idea is it could rewind. Oh, okay, sorry, I expected this to suck way more, but it's actually not too bad. Let's make the gravity a bit more aggressive. Let's make 10 times the gravity and a lot more restitution. So it's now almost completely elastic. It's going to be like a boingy bouncy ball. How bad does that look if I make this full screen? I mean, it looks ridiculous. Let's say I'm here and this bounces. Well, the bounding box for this is so horribly set up. It's hard to tell because it looks stupid anyway. This is bouncing. Interesting. Let's give it a little bit of velocity, lateral velocity. So instead of bouncing up and down on the spot, it's going to go all over the dang place. Ah, yes, this is where things get kind of silly. Because I never bothered to work out the proper collision normal, but that's fine. And of course there's going to be huge problems if it goes between rooms, although I'm pretty sure it would crash. It's a bit hard to aim it. Maybe from here. Whoa, further back from here. The bounding box is set up so badly. Oh, there we go. Wow, it didn't crash. Oh, wow. So, okay, one thing I want to do right now is try and figure out a slightly better bounding box for these things. And I think I might do that by going into Blender. I don't know why there's always a default cube. I guess Blender is just quirky. Let's import that obj file. Hyper2 data picnic face. Now, how can I... Oh god. I actually don't know anything about Blender. So how can I Blender query bounding box with a script? How do I extract the bounding box of a model? Every object in Blender has a bounding box probably. Okay, so let's look at this. Looks like some sort of thing. Scene. Oh, how can I look at its properties? Don't know. Maybe it might be easier to hack the. Maybe it would be easier to hack the importer. Oh, it's all like scripts and stuff. So is it not going to show me at any point what? Oh, well, there's some tabs. Scene. If only a Blenderific Blender person was watching this, they would be able to direct me. Oh, there's some bounds. But what are they? Lots of cool stuff in here. I don't know what any of it means. Well, I know what a lot of these things are, but I don't really know how to do anything with them. Okay, so I can't really see where it might be just by clicking around a little bit in Blender. That's too bad. There's some tabs at the side. Oh, wow, very exciting. No, I'm not getting anything from this. Not very useful. Well, let's look at the import. When we import model, it might be nice just to have a quick peek at the imported state of it. So a mesh is made up of multiple models, each of which will have a bunch of vertices. So that forms into a mesh of vertices. The mesh itself has a vector of vertices. Easy peasy. Oh. What's the standard if-def debug? You know I never do if-def debugs. Is it debugged? Have I even defined that in my make file? I don't know. Let's check. Oh, I'm going through random things today. So if release is defined here, Otherwise, C flags is just that. But there's no real difference. Well, I'll just put it behind the if def anyway. Whoops, my comment wandered away. Okay, what do I want to do? We're just going to, after the mesh is loaded, loop through all the vertices and just try and find sorry, we don't get the positions out, we get vertices. So GLM min and GLM max are a component-wise minimize and maximize function. Also, that should definitely be const. How broken is that piece of code? It's not too broken. Okay, and then let's just do a little report on what's been loaded. Just output a few stats about the model, because that's useful. We actually might need to do this to offset the bounds a little bit, maybe. Because at the moment, there's no guarantee that the model is centered around the origin, so having just a bounding box that's the size of the thing isn't great, because the assets that I attach to things cannot be organized by position. Wow, my USB charging cable is really broken. Huh. Well, I hope that keeps working. I don't want to be forced to pick up a new one. You can do GLM type pointers and stuff. But they're not particularly pretty. Okay, so this should give us the bounds in the model, and then we can test that against a terrible little. Yes, it's totally not centered. But nonetheless, I can see that 1.83 and 1.95, so if I go to the testing and set that about 1.9, that's fair. The other one, 0, and 3.3. Well, let's just set it to 3.3. Wait, what was it? 1.5. That was too much. Well, maybe this is not lying. Negative 4.2 to 3.7, so that's about 4. That seems wildly wrong. But let's give it the benefit of the doubt. Okay. Let's change this to 0.2 because I think the 3.3 is upwards. So how does that look now? You know, it doesn't even look that bad. That's the worst part. That's an object that's moving at quite some speed. Well, not a huge amount of speed, but what's the chaise longue? 1 to 3, negative 1.8 to 1.1, negative 4.49 to 2.19. So if I get all the way down here, I should be able to see pretty clearly that these are not really hitting. But the bounding box is still wrong anyway. Let's center them. So what do we want to say? It should be half size is where, so the full size of it is the maxes minus the mins, but we want it to be half of that because we want half of the size. So we really want 0, 0, 0 to be where that is, or rather we want maxes to be where that is. So if I just make a GLM vec3 offset and set that to be h size minus maxes, and then for that vert pos plus equals offset, really positions plus equals to the offset. Pos is a vec3. Vec3 cannot be plus equals. It's because it's const. So with a bit of a post-processing step, I can probably center the model. Is it important for a model to be centered? I don't know what the standard is for this sort of thing in 3D game design. Probably not. So for this, I can now see that it's given this exact bounds. Do I want to center the models? I don't know. Maybe. Let's look at the cheese launch. It says 1.34. 1.5, which is correct. 3.35. That's what it says the bounds is now. If I do that, will it now perfectly fit the bounding box? Yeah, looks like is accurate. This side-to-side bouncing is very silly. Boing, 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 boing. If we load up this one, 1.89, so 1.9 is fine. 1.6, 1.7 even, and 4.0. Let's have a look at that. Where's it gone? There it is. I can really get right close to this. I mean, is it just me or does that look not too bad? I'm not looking to do high class physics here, I just want to do a little bit of box piling up, moving around. Not really piling up even. So they're not touching the ground. And I'm not even, oh my god, are they falling through? Wow. That works way better than it should because I haven't put much care into any of this. Like, I think it's reading the voxels out of bounds. For how terrible I was trying to make this, it's actually not too bad. And that's kind of... I was just trying to hack it to be something that did a thing. And what I got was something that did a thing a lot better than I expected. And considering how badly implemented the original physics were, because they were overcomplicated in the original prototype, it doesn't even seem that bad. If it's sub-stepped, like, whoa. Yeah, okay, so definitely there's problems there. With okay, one of them is glitching out, and the restitution has absolutely no dampening. Ideally, you want the restitution to have some, or there should be some friction, so that you lose energy in every jump, just a set amount. Which means when you get to the point where it's bouncing like this, it evens out a lot quicker. Yeah, this just seems to work slightly better than I expected. Which is good, it's a good thing, let's be honest. That actually... Oh, there we've got stuff. I see, this is where the 40... I looked up at that table and it just drifted upwards away from me. That's cool. If I do this... then I can get some very strange physics going on. They really don't handle room transitions, or they are possibly colliding super hard. Okay, so what do we have here? A terrible, terrible implementation that just resets positions, but the results are okay. They're not too bad. Are they good? No, I wouldn't say they're good, but are they good enough? Quite possibly. Especially if it's subdivided to physics and ran it over a few time steps. It might actually be it might actually be sufficient. What isn't sufficient is the code that runs this. It just loops over the voxels, finds the very first voxel that collides. It doesn't even derive a contact normal or anything, which is why it just reverses along the velocity. But how's about this? This is a bit of a off-the-cuff idea. Loop through the voxels, find the best collision. What's the best collision? It's, I guess, the one with the biggest penetration. Charming word. Where in the picnic table example, if it hits a bunch of voxels, you want the one where it's furthest in. So if it hits a side, or it could just literally gather up all the sides that it hits and bounce off all of them. As in, if it hits two sides, it's got a diagonal, normal. Then, if it has a collision, reset its position back to the start of the frame and adjust its velocity based on the formulas from Wikipedia, but actually taking account of the contact normals. Yeah, that's what happens when you read voxels out of bounds. So, I must say I did like this thing. Oh, I just take this if statement out. We're just going to put a different comment in so it looks like I meant to do this. Post-process model to center it. Now, am I going to always center it? Let's European spell it. I don't know. Should all models have the origin in the middle? Probably not. In fact, I think it makes sense to have the origin at the bottom of the model. Oh, goodness me. But, it's still kind of useful for it to be sort of centered for now. So I'm going to keep that for now. The great thing about code is you can always delete it. Find min max, center the vertices, and find half size. Okay. I mean, to me that's just a straight up win. And it gives some information out on the command line. It's good enough for me. Let's... No, I don't want to add this stuff in right now because it's not quite perfect. But I can definitely check back the bit that center models and print stats. Loading now. I just did commit. I forgot to type git. That's a new one. Whoa! 666 in my commit ID. Unbelievable. Git push. Wow, I'm really on a roll today. Okay. I'm fascinated that that physics didn't look as bad as it should have. I really expected it to look like complete garbage, and it looked okay. Just resetting the position back isn't really a particularly helpful thing to do, because I'm going to have to be tactical, because it can move from one reference frame to another. And then if you just reset the position, oh, that's probably why the picnic tables are teleporting actually. Just change the position to something else. If it bounces on the frame where it also moves through the portal, it's going to just go... Yeah, okay. You know, this has given me a whole bunch to think about. What I'm very tempted to do is make the physics extremely rubbish. I want it to be responsive and it to work nicely, like to feel reasonably nice, but I don't care at all about realistic physical simulation. I want it to play like a video game. If things stack up in weird ways or whatever, you know, it's cool. People really don't care about that kind of thing. And physics puzzles are the worst anyway, so I'm cool with that. But is this terrible enough to have this work? Gosh, I don't know. This is really surprised me, because I expected that to look so bad that then I would have to implement a rewinding algorithm where you would test the object against the voxel and find the collision normal and match it against the velocity and wind the object back to the point where it wasn't penetrating and find out how much of a wind back that was, and then check all the voxels and find the least winded back one. So just setting the position to the old position was a really hacky proof of concept to show that all of the effort I was going to put in on this stream into doing all the other stuff would be worthwhile, because it was like, oh look, it does the job but it looks bad, so we can make it look good. But the problem is it did the job and it looked good anyway, so why engineer further when it already does something that I want? Perhaps it's going to have worse edge cases later, I don't know. But I guess the way to progress is to have the body's position able to wind back. So the one thing you do need to know is what's the collision normal. So I still need to check the voxel and find out what the collision normal is likely to be. How would I do that? For an individual bounding box, I can just trace so I could trace it. Let me think. So it's going to be paused to the it's in the comment. It's trying to autocorrect me. It's from the position. See, I'm trying to draw a real arrow. Not. It thinks I'm trying to use it as a pointer when it's not a pointer. It's correcting me, which is appreciated. But what I'm trying to do is think algebraically here. Not algebraically. Geometrically? I don't know. So it's from position to the voxel center with the half size plus the voxel size, which is 1 by 1 by 1. So the half voxel size is half. Easily done. So we can actually just... So if we find the distance from the position to the voxel center... Oh no, we want to test velocity against it. Do we? So this is to do with, I can't remember what it's called, like Minkowski something. But basically, if you have two boxes like A and B, and you want to test if this will collide with that one, what you can do is shrink this one down. That's the sound it makes. Okay, so now it's just a point. I've obviously done a great job with that. And at the same time expand this one out by the same amount. Bleh, 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 bleh. And then the point where it collides, the collision normal you get from that is the same. The solution does not change. So if I have, if I have a voxel, which I'm, again, there's a box tool. I should just draw boxes with that rather than draw my horribly badly placed ones. So if we've got something like this going like that, then we have a point here and a point here and a size vector that's like but it's also got the size of the voxel, so it's like this size. So you can think of it like that. So this point travels like that. We want to find this location here, because when this is here, my picture is not very accurate. That should be where it collides with the voxel. So how would you find that? Well, you would subtract this distance and this distance, so you'd have the travel distance and you have the velocity, so you know the rate at which it travels them. No. Yes. Is that right? So for it to be colliding, it needs to be above here and above here. So, because this is the bigger one, that's the point, which will be here. On this one, it only enters, it crosses this line of the voxel, but you need to cross all the lines of the voxel simultaneously. So no, there's more to it than that. I've oversimplified it. But anyway, it's something like that. And anyway, whether that's X, Y, or Z, positive or negative, will result in both a time parameter and a collision normal. which actually would let me rewind based on time, but considering that could result in crossing into different rooms and stuff, just resetting it to its previous position is probably fine. As long as I subdivide, like this time step here, float delta, that's just the frame rate. So if it's 60 frames a second, it's only going to do 60 steps, which is probably okay, but you can divide that into 2 or 3 or 10 or whatever, so the physics is a lot more fine-grained. That will make this hack less terrible. Now, I don't think I want to divide it too much because this does a lot of weird stuff. Well, this isn't weird, but all these matrices, which is actually going to have to do like a sort of searchy thing to check it's going to be convoluted. Convoluted to code. Will it be fast for a computer? Yeah, it probably will be pretty fast. It's going to do some very basic maths, some if statements, and some more if statements, a whole bunch of branches, most of which will pass anyway, so that won't be particularly much. Then it's going to go through each one, check some voxels. So, that's something that definitely could be improved. The voxels that it checks, it doesn't need to check so many of them. But maybe it doesn't matter if it does. I don't know. Oh, I'd also like it to be able to step up a voxel. Maybe I can do that with colliders. So if the player is hitting a voxel with his feet or her feet, probably her, because I always make female player characters, and they can step up one voxel and keep moving, then that would be nice to do. You wanna do that because then they can walk upstairs. Hooray! It's not so bad. Especially if I keep my voxels reasonably small, that will be pretty nice. Okay, so everything's completely derailed right now, but that's fine. Checking if the two of them overlap. First I need to check the bounding boxes, and if they don't overlap, I need to check something else. Check each fixture. If they do overlap each fixture. So another thing is, okay, so this force impulse could probably just become an acceleration. I'm not getting a lot from the whole idea of impulses, other than that's kind of more realistic or whatever for how physics works, but ultimately what happens is the velocity changes. Mass and restitution are fine, and in fact do not change with your reference frame, nor does friction or anything. The intrinsic properties of your physics body are all good, but it might be really helpful if position, half size, and possibly velocity. No, possibly not velocity. Were projected into, or at least position and half size, were projected into the target reference frame, because they are going to be anyway for this, and then if they also do, so when I said for this, I meant for the voxel check, they're going to be projected, and for body to body or fixture to fixture collisions, they're going to be projected. So because these are inevitable, it might be worthwhile just saying, hey, okay, let's put them into the basis reference frame and work from there. Anyhow, I'm tired, and the stream went off in a weird direction. I need to sit and implement some stuff tomorrow in a test branch and then work through it on stream. Because that is surprisingly, I did not expect that to work at all well. Anyway, no one's about, so I'm probably going to end it right now. I'm tired and I don't have a solid idea of what I'm about to implement. And it's getting pretty late. So it's just a short one today, just trying out an idea and discussing silly things. I hope you had fun. If you watch this, other than that, cheery bye.